Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
For this problem, we are given a scenario where there is a block attached to two separate springs on a frictionless floor, and we're trying to figure out what the frequency of oscillation is going to be on that block. So we have a bit of information. The first thing that we know is that the mass of the block is 0.245 kilograms. And we know that our spring constant for both springs, because they are identical, is 7,580 newtons per meter. All right, and we're going to use two different equations to help us solve this, and both of them are related to force. The first one is force equals negative mass times omega squared times our amplitude, and the second is going to be force equals negative spring constant times our amplitude. So again, giving us two equations both related to force. And because they're both related to force, we can actually make them equal to each other since we're talking about one particular system. So I can have my equation related to my spring constant equal to the equation related to the mass times my omega. Now, because there are two springs, I am going to have to double my spring constant portion of the equation. So what my equation is eventually going to look like is 2 times k times my amplitude is going to equal my mass times omega squared times my amplitude, my xm. And we can get rid of, because we put them equal to each other, we're able to get rid of the two negative signs. Okay, so I can also swap out my omega here because I eventually want to find my frequency, and omega also equals 2 pi times the frequency. So now when I substitute that in, my new equation is going to be 2 spring constant times my amplitude equals my mass times 2 pi f squared, again, times my amplitude. But now I'm able to solve for frequency. So I'm going to rearrange my equation. When I am changing this to get my frequency by itself, the first thing I'm going to do is divide both sides by my amplitude. So that gets taken out of my equation. Then I would divide again by my mass. So I have my 2 k, which is my spring constant, equals mass times my 2 pi f squared. Divide both sides by my mass. So that divides out on that side. If I keep going, I'm going to want to take the square root. So I'll have square root of 2k divided by my mass equals my 2 pi f. And then finally, divide both sides by 2 pi so that my frequency is all by itself. So in the end, my final equation for frequency is going to be frequency equals the square root of 2 times my spring constant divided by my mass, all divided by 2 pi. And I can start substituting those values in. So I know that my frequency is going to equal the square root of 2 times 7,580 divided by 0.245 245 divided by 2 pi, and that gives me an answer of 39.6